What'd you find, Zach?
There's one tricky looking capacitance one.
Oh, okay, good. Yeah, what year?
1718 B2.
Let's see.
Question B2.
Let's have a look at what's so tricky.
Okay, no, that's not that tricky.
Ah, am I opening? Maybe. Well, let me have a look at it. I'll tell you.
Oh, I guess.
What else are people thinking about it? You're like, yeah, maybe.
Is there sport capacity?
Yeah, but it depends.
V0E. Draw card.
Why isn't this opening? Here we go. Right, what number did you say? Oh, sorry, that's not on there. Well, you have it on your phone. B2?
Yes.
B2 1718 version 2. End of semester 1.
Oh, end of semester 1. I was looking at end of semester 2. 1718 version. Sorry, what version, Zach?
Also, it's actually not that complex.
What version am I looking?
Version 2.
Let's have a look.
No, anything that's electricity sounds fun.
Let's see, what's the deal?
I just saw the circuit. Okay. But it's actually not fast straightforward.
Okay, I don't think B2 is that mad.
Yeah. Should we find a better one? Kirchhoff's one?
Yeah, I really want to be doing a Kirchhoff one.
Okay.
We might have to be looking at the semester 2 exams. Let's look at 18-19 semester 2. Oh, there's only one.
There's only one, yeah.
Well, let's see what it was. Maybe it was a Kirchhoff.
Pretty interesting one on photoelectric effect.
Now, do you know what, actually? I want to do an electricity, but I also... No, screw that. Sorry. Let's check next year. I forgot we haven't done waves yet. See, 1718, let's jump down to version 5.
There's nothing.
Nothing in version 5?
Well, no, Kirchhoff's one.
Are you sure?
Yeah, I just looked at
Kirchhoff, where are you? Okay, we might have to go older.
Yeah.
Whoever's been writing the exams recently hasn't been writing as many Kirchhoffs.
I looked through 1718, so.
No, there's nothing there.
I'll take 14 to 3.
I just woke up on there. Morning.
Well, now, what did I say to you yesterday? What did I say to you yesterday?
I know.
What did I say to you yesterday? Tell me.
No, late.
And why are you late?
No explains. No explanation.
16, 17, B3.
Is that Kirchhoff?
I think so.
Right, let's have a look at it. 16, 17, V3.
Question B2.
No, well, that's the potential dividing.
Well, it has internal resistance.
There's also, I don't know if you've seen it, there's another mechanics question I wanted to do, but I don't remember what year it was. It's the one where there's a projectile going up a hill, which is kind of hard. But I don't think you've seen that. Oh, I found the trapdoor one again. Goodness. Oh wait. Aha. I found a question. I found a good one. It is half potential divider and half Kirchhoff. That's good.
Is this the 16, 17?
This is no. I just opened up 1314, version 1.
14.
version 1.
Oh. Ah.
B4.
B6, the last question.
B4, 4.
Do you have it open there?
Yeah.
Now, I like this one because it has two topics in it, potential divider and Kirchhoff, which is good.
It's allowing to the speaking example.
Thanks for sending me some email.
No fighting, it's Christmas party day.
Just
No.
because they don't send you email.
I actually forgot.
Right. While you're working on that one, I want to find the mechanics question I wanted to do. So let's see, 20 minutes for that one. Clock and go.
You mean that covering all the voltage?
Do you know what could be why I can't access my Windows account?
I don't know, man. What did you do? Maybe you've been hacked. Yeah, maybe someone's trying to steal your identity on Moodle. It's like, I'll pretend to be Diego and do all his homework. Ha
If you can't do also the exams for me.
Is that be great, huh? Bong, 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 bong. Time up. Right, so that's been 20 minutes. How did we fare? So Dorian, did you get it finished or where did you cut off at? Bad? Did you get much of Kirchhoff?
No.
No?
I didn't either.
Oh wow, okay. Gina? Wow, okay. Well, I know Lynn, you've just arrived 3 minutes ago, so you two?
Just finish with the
Alright, let's look at this now. Okay, so the first thing, define resistivity. Now let me give you a little pro gamer tip here. I like to write down the formula to help remind me of a definition I could come up with. Resistance equals rho L over A. Okay, so you have resistance is proportional to L over A, right? That rho there is what's called a proportionality constant. So get my spelling right, resistivity is a proportional constant necessary to determine the resistance. Do you know what, actually, for some reason I feel like I want to put the or in a different colour because the or in the formula. Resistance. Oh, whoops. Screw it. Resistance. Did I get that right?
Yeah.
Determine the resistance in a conductor, of length L and cross-sectional area A. But also, what I like to do here is you can rewrite this as rho equals or A over L.
Yeah.
So, what's the units? It would be ohm meter squared over meter. So in other words, it's ohm meters. Okay. So you could also say, and you know what? I'll put rho here. Rho is of units ohm meters. It is also the, now if you look at the formula here, you could say it's also the resistance area per unit length. It's also the resistance area per unit
You-
length. Now,
The definition they give is really strange.
no, I know, but see, this is the thing. There's flexibility. I hedge my bets. I want to make sure I write enough so that whatever marks are going, I'm going to catch them. Okay, so you read the definition there, Zach. Now, it's 2 marks, isn't it? So tell me where the first mark goes. What's it say?
Doesn't even say where.
Okay, well, you can read the definition.
Resistivity
Yeah.
is numerically equal to the resistance of a cube of material with unit cross-sectional area and unit length when the current is flowing parallel to one edge. What does that even mean?
It's a very awkward way of saying what I said at the end here.
When the current is flowing parallel to one edge.
So if it's going across, it's not the
It,
same.
it means that the current's passing through it, from one face to the other face. So
If it's a cube, that means it's
yeah, but what they mean by parallel to one edge. So if we take the top edge as an example, parallel to that edge would mean the current is going through it like that.
But then if it's going from one corner to the other, then it's not.
Yeah. The reason they say that is to guarantee that it's perpendicular to the cross-sectional area.
so isn't that what's implied by cross-sectional area?
Well, that's what I'm saying. The way I wrote it.
Parallel, yeah.
Yeah, the way I wrote it. Is that all they say?
Yeah.
Ah, fine. I went, well, not that I went overboard, but I definitely get the marks here.
You can write a lot, as much as you want, no? Or do you get
Don't
too
write
much?
No.
5
No,
million
the-
words.
No, I mean like,
The
let's say if you...
The optimum strategy is you make sure you hit all the points by writing as much as you can reasonably. So, like, do you see here?
Not 10 sentences.
Not 10 sentences, but
3, 5.
this first one here is in case there was a mark going for knowing that the row is necessary to remove the proportionality. Okay. Also, maybe there was a mark going for knowing that row determines the resistance. Maybe there was a mark going for knowing the formula, row L and A. Maybe there was a mark for the units. Do you know what I mean? When the question is 2 marks, all I know is that they're 2 marks. But I don't know what the 2 marks are going to be assigned to. Maybe it's knowing the units. Maybe it's knowing the formula. You know? So why not just hit all the points and make sure you get the 2 marks? And sometimes you notice that when they ask you for, like, say, 2 things, there might be a list of 5 things in the marking scheme and you just need to get 2 of them. You know? So like I said, hedge your bets.
Yeah, I think
Okay.
that's how they are in the more recent.
Yeah, I think so too.
mark schemes.
Yeah.
This is the 30s.
This is an older one, yeah. Right, let's look at part 2 now. Okay, so the next one is simply to use the formula, isn't it? Yeah, so that's straightforward.
Then you have to get diameter.
Yeah.
Yeah, row, what is it? 1.1 times 10 to the minus 6, yeah?
Times 2.
Times 2, and what have they given us? The area? The
resistance 10.
Oh, they want the diameter and they give us this.
R is 10.
And
So you can do pi.
what do they want exactly? The diameter?
So you can use pi.
Yeah, so this is pi,
D squared over 4.
yeah, or d over 2 squared.
D over 2 squared.
Yeah, it's the same thing.
Oh yeah.
Yeah. So, with a little bit of rearranging, we can get d squared. Now, what I'll do is I'll multiply the top by 4 and the bottom by 4, thus cancelling that. And if I divide both sides by 10, that becomes now 7. So the d squared will be 2 times 4 is 8, isn't it?
Yeah.
And 8 times 1.1 is, no, you don't need calculators, 8.8,
Times
10 to the minus 7
over pi d.
over pi, and I brought the d squared up.
Root.
So d will be root the whole thing. So I'm going to change this into root, because I don't have a calculator, multiply by 10, divide by 10, 88 over pi times 10 to the minus 4. So
5.29
times 10 to the minus 4. Now what I'll do is I'll divide this by by 100 and multiply this by 100, so I can write the answer quite nicely as 529 micrometers for the fun of it. A reasonable answer.
How do you even make a wire that's 529 micrometers?
Well, 529 micrometers is bigger than it sounds, because this here, if I divide this, if I multiply this by 10, and it's half a millimeter. That's not unimaginable.
Yeah, no.
It's not unimaginable, because you can easily see a millimeter on your ruler. So it just makes it sound tiny when you're measuring in micrometers, you know. Got 529 of them. Right, next one. Is this okay? Yeah. Right. The nichrome wires used to make potential divider. Determine the length of nichrome wire. Is it the same wire? Yeah. Right. So you know the formula here. V out equals, and then on the bottom here is V in. No, sorry, what am I saying? V out equals, and then at the bottom here it's R1 plus R2, V in, and then on the top is R1. Is that the formula? Yeah? Isn't it?
Yes.
Yeah? So, what do we know? Do we know V out? We do. What is it? Come on, Lynn. What's V out? Guys, don't pretend to be stupid now. Come on, what's V out? Guys! Zach, look up. Look up. Look at the TV. What is the output voltage? Oh no, don't give me, no, this is some kind of Christmas joke, isn't it? 3, yeah. And what's the input voltage? 12. So what is this potential divider doing? Do you remember what we said they do? They reduce the voltage.
Yeah.
So this one is reducing a 12 input to a 3 output.
Oh, yeah.
Isn't it? So 3 equals, now we know the total resistance of the wire, it's split in 2, but we still know the total. What is it? I think they said it was 10, wasn't it?
Yes.
And we know the input, don't we? What was it? 12, right? And we can calculate R1 from this. So R1 would be 30 over 12, which is 15 over 6, which is 5 over 2, which is 2.5 ohms. Right? Now that's not what they want.
They want the length of the wire.
I know, I'm getting there. Now you can do this very neat trick. You could,
just use the scale.
the scale, yeah. If R1 is 2.5, then you know what R2 is. It's 7.5. Now you could use the formula to calculate L. However, you have this nice little fact, if you think about it logically. If the total wire is 10 in resistance, and everything is uniform and same behavior, then the resistance is proportional. Yeah. So if it's in this proportion, it must be the case that R2 is 3 times the size of R1.
0.5.
So what is the length of the wire?
0.5.
2 meters. So yeah.
Oh, yeah.
0.5.
But the thing is, I just did it like
I
3
just
over
said-
12 times 2. That's basically what I did. 3 over 12 times 2.
Would that be acceptable?
Yeah.
Or did you just get lucky?
Because if the resistance
Yeah, I
is
did
the
that
same,
too. I said
then it
12
should
to
be-
3.
isn't it like resistance should be the same?
So
and
the
I
scale
guess-
is 4 to 1, yeah.
Okay, I'll allow it. Right.
Okay, but we did that same thing.
I think. Well, look, how I wrote it. No, you're playing with the same concept of the resistance being proportional to the length.
Yeah.
Yeah. Okay. What's next? Right. V. Part 4. A 5 ohm resistor is connected across the output, so that would be, I'd imagine, here. Determine the voltage now. Okay, so let's redraw the circuit. Can you look up? We're going to redraw. So what did we say the input voltage was? 12 volts, okay? And then the first resistor is the long one. That's 7.5 ohms. And the second resistor, it was 2.5, wasn't it? However, there's now a resistor in parallel with it of size 5. So what do we need to do? We know the deal. 1 over R is 1 over 2.5 plus 1 over 5, which is 2 over 5 plus 1 over 5, which is 3 over 5. So that means R is 5 over 3, which is 1.67 ohms.
V times I.
Oh yeah, they want the V, don't they? Well,
Current.
so
Oh no, potential difference.
they want the V?
Yeah.
V equals IR. Now, do we know the I?
No.
No. We'll have to get the I, won't we? Which means we should get the total resistance.
Yeah.
Okay, total resistance is 7.5 plus 1.667, which is 7.500, 1.667, 7, 6, 11, 9.167. VIR, the I is V over R. Okay, I've run out of brain power now. 12 over 9.167
1.31.
amps. So the V we want is equal to IR, which will equal 1.31
It's 5 over 3.
times 1.667. So what do we get here?
24 over 11 or 2.18 recurring. So 2.18.
Oh, 2.18 recurring, so that'd be 2.19. No, the next one, the 181818?
Yeah.
Okay. Do you actually have the answers open, Zach?
No.
Okay. No, I just wondering if we could check it.
Well, I can
Yeah.
open it.
Yeah, please. Because I just want to see if we're doing it okay. Now, this is interesting. This is interesting because...
They don't even show them.
No, look up, look up. This is interesting because the next thing to do was to get the current.
Strange. Why did I ask
So there must have been some way to do this without having to need the current.
that? Yeah, so they did.
Wait a second. Well, just before you tell me, so what we've actually done is here we've actually done V part 6, and here we've done part 5. Now, there's no rule in the exam that says you have to do the questions in order. And I've discovered over the years that sometimes in the physics paper, it's actually convenient to swap 2 parts. You probably have noticed that too sometimes. Right, so now tell me the secret of doing this without finding the current. What could we do?
So they say this will be in parallel with the following resistor. 1 over RP equals here, 3 over 5. So they get the 1.667.
Yeah?
Hence V out equals R2 over R1 plus R2 times V in.
Oh, they used the V out.
Oh, they used the potential divider formula, of course. So once they got the new resistance, they just plugged that into the formula.
Yeah.
Well, actually, the way I did it is kind of better. It's a little less work. Yeah.
After part.
Yeah, it helps with the second part anyways. Okay, can we continue? Yeah.
So next one is down already, 1.31.
The next one is a Kirchhoff, is it?
Yeah.
Yeah.
No, 6.
No, about 6.
There's a part 6?
But didn't we-
Yeah, we did it. It was the current. I accidentally did, the way I did it involved me getting the current first.
No, it's not the same.
Huh? No.
Part 6?
That's
Why is there no part 6?
What?
Well, there is.
No, don't listen to him.
Time frame through the
Determine,
length
yeah, I've done that.
CV.
I've done that.
What was the answer?
Oh,
AC and CB. It's
oh
not
no,
the
it's different. Sorry, CB.
Okay.
That's different. So, okay, rats. I thought I did it the smart way. So, well, I could still use that answer. It would still help.
same. And you just go I times R times 2.18.
Well, that now just to be clear, guys, look up, look up, look up, Gina. Thank you. This 1.31 is the current here, okay, and here, and here. But I think the question is they want the current through CB. Now, where do they put the resistor? Yeah, I think they want the current here.
Yeah.
Will it be 1.31?
No.
No.
Split.
Yeah, will it be more or less?
Less.
It'll be less. What's the easiest way to get it? V over R? Do we know the V?
Or you can say, yeah, V over R, yeah.
No, it's not 12. Both together is 12.
V over R.
Do we know the V?
Yes, 2.18.
We do. We do. No, he's right, we do. No, we do. Look. That 2.18 is here, and they're parallel, so they're the same.
Okay.
Yeah. So I equals 2.18 over
2.5.
2.5.
0.872 recurring.
V, I is V
0.72 recurring.
over R. Yeah. What is it?
0.872 recurring.
And is that the answer?
Yeah.
Okay, so we're good. Okay.
Yes, it is.
Okay. Is that okay? Yeah? Right, now, on to Kirchhoff. Right, so how did you get on with Kirchhoff?
This one was
No, come on, guys. Come on. Right, let's do this together. Diego, where will we start in the circuit? Let's start with the 10, huh? So, let's do this. 10 minus, what's next, children?
2.10 times 8.
2.1 times 8. Now, let us go up. So, that E1, plus or minus?
Plus.
Plus.
No, minus.
No, plus.
Oh, yeah. Plus.
And then the 4,
4 times R1.
plus or minus.
Minus.
And then finally, the 2.
2 times 2.1.
Very good. 2 times 2.1 equals 0. Now let's go along the bottom. 10 minus 2.18 plus E2.
16.
Oh, we know it. Okay. Plus 16 minus
6 times
I2 minus 2 times 2.1 equals 0. And then lastly, here, I1, 2.1 minus I1 minus I2 equals 0.
Yeah.
Okay, so what the heck's the problem here with this? We've got 3 equations, 3 unknowns. What's the problem? Nothing, right? Nothing's the problem. The question is, though, which variable do we cancel first?
They want R1.
No. This is important. Wait, look at me. Look at me. Look. Shh. Don't say anything, just look at me. No, look at me. Okay, thank you. It is not important what they ask here. In fact, I would even say ignore it. Okay? You just solve this in the order that's easiest. So for example, if you find E1 first, fine. Just say part 3 E1 equals. Right? It's so not important. You need to do it in the order that's easiest. And I said the easiest thing to do first is to cancel what is in all 3 equations. Now what is in all 3 equations? You can find the I2 straight away. Okay, so there's nothing in all 3, but as Gina pointed out, the second equation gives you I2 straight away. Now, what do they ask for first? They ask for I1. So it's actually easier for me to do the second part first, which is to get I2. Okay, so let's do that. So this is part 2's answer. I2 will equal 10 minus 2.1 times 8 plus 16 minus 2 times 2.1 all over 6. And then I think what would be easiest to get next would be I1, which is actually the first part here. I1 would equal 2.1 minus I2, which we can get now in a moment. What is I2, please?
0.833.
Thank you. And so this would be, what would this one be? I1. 1.2. Yeah? And then finally, which is part 3, is to get the E. So E1 will equal minus 10 plus 2.1 times 8 plus 4 times 1.27 plus 2 times 2.1 equals.
Can't you just say E1 is 16 because the voltages are split in parallel?
I don't know, I'd have to look at the diagram again, but let's see what we get out from this. It might not be 16.
I thought it was like that, but it wasn't.
Yeah.
But it wasn't.
Yeah. What do we get here?
6.08.
6 point,
16.
16 point? No, so he said 16.08, so 16.1?
So it is 16.
That might just be a coincidence there, don't get too excited. You're saying E1 should be 16?
Because
No. No, why should it be? You can put any battery there, any cell there, right? There's no law that says you can only put a 16 there, you know? Were you thinking of the fact that because they're in parallel, the voltage is the same?
Oh yeah.
That-
I didn't realize it was cells. It was just like a resistance.
Yeah.
Voltages would
Yeah,
be the
being
same.
supplied externally.
Yeah.
Yeah. Guys, so look, 6 marks. Not that hard, right? So, what went wrong here? I thought this one was actually an easy Kirchhoff.
missed out some numbers.
Yeah. Is it okay? Is it? I'm looking at your faces and I don't know. Lynn? Yeah? Is it okay? No? Is it? Now, is this okay, Gina, for you? Yeah? Not for you, but is it okay now or not? There's a mechanics question I want to do because it's interesting. It's the one in version 3 of the same year. It looks like this is B4. Look at it, it's great. The block sliding down a hill. And then the best part is in the second part, the block or the ball gets thrown down the hill like this. It's a fantastic question. Great projectiles question too. So I think it would be great if you did this one. And let's see if you can do it in 20 minutes.
Yeah, let me just take a picture of it.
Yeah, you tell me when to scroll down.
Yeah, you can scroll on.
Okay, so you need this part now?
I need.
Yeah, you do. You need this part.
3.
Yeah, you have it there. And
Yeah,
then
okay.
and then you need that part lastly.
Okay, perfect. Thank you.
Good. 1 minute. Okay, okay. Let's have a look at the answer. So, I promised you that in the first part you can do this without resolving gravity. So we can say that the energy at the start, which is a half m v squared plus m g h, should equal the energy at the end, which will be a half m v squared. So I can get v will equal the square root over 3.75 multiplied by 2, so that's 3.75 times 4.5 squared, plus, if I multiply that by 2, that's 3 times 2 is 6, 7.5? 7.5 times 9.81 times 30 times sine 25.
So you're telling me that's easily d squared equals u squared plus 2as.
For me it is. Just more to type. Well, so what's the v?
V is 16.4.
Okay. I'm going to assume that it'll be the same when I type this in. I'd be horrified if it wasn't. Okay? Yeah, you want to check it in? That would be great, yeah. Part 2, they want the momentum, which will be... Oh, I should also say down the plane as well. P equals mv, which will be 3.75 times 16.4. So what's that?
61.5 kilograms per meters per second.
61.5 kilogram meters per second down the plane.
Yeah.
And what was part 3 asking you for?
Time.
Time. Alright, so that's just
V minus
v equals u, v squared equals u, s equals
v
u.
minus u.
But, oh, the way I did it, I don't have a. That's foiled. I would say s equals u plus v over 2t. So then t will equal 2s over u plus v, which would be 60 over 16.4 plus 4.5.
Why would we don't have
The way I did it, I didn't calculate the
to
a,
pay?
just the way I did it. So what is the t if you calculate it this way, Lynn, if you type this in?
2.87.
Is that the same answer you got?
Yeah.
Seconds. Yeah? Okay, so have I done part A?
Yeah.
Yeah.
Now on to the juicy part. Part B. Now let's have a look. An object is thrown horizontally at 12.25. Determine the time for it to hit the slope and determine the distance from the top of the slope where the object hits. Hey, hey. Okay. Whoa, hang on, hold on. I know what I'm doing, I think.
Is there the other one?
Oh, it's the other way. No, I guess I don't know what I'm doing. Okay, thank goodness. Right. Alright, so if you look here, this is what's happening. The particle on the top is fired horizontally with a speed of 12.5, thank you. 12.25 meters per second. And it'll go bum 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 and then hit down the plane here somewhere. And we don't know the time and we don't know the distance. I doubt it's 30. It'll be something different. Is the angle still the same, right? Or is it at 25 degrees? We have a picture like this. Okay. Now here's the trick. You imagine for a moment that you are standing here on the plane. Yeah? So you are imagining that your world is like this. In this world, will gravity be acting downwards? No, because if we go back to the first picture, yeah, gravity is acting like this, isn't it? But we're going to imagine the world is like this. You're standing on the plane, on the ground. And gravity won't feel like it's perpendicular to the ground anymore. It'll feel like it's at an angle, requiring us to resolve it. So we will feel like we are being pushed to our right and down as well. Now, if that's 25, then this has to be 25 as well. So we know that this one here becomes the cos. G cos 25. And this one here becomes G sine 25. Yeah? Okay. Now, what are we looking for first? I think it's the time. How do we normally find the time for projectiles? We look horizontally or vertically? We look vertically. What's the U? Well, we'll have to calculate it. So we'll need to resolve this here and here. Now, we know this angle. What's that angle? Who can spot what this angle is? Yeah, because this is parallel to this. Because remember at the start of the story they said that it's horizontal. Yeah, it's all imagination now, isn't it? So this one here would be 12.25 sine 25. Whoa, no, don't. And then this one here would be 12.25 cos 25. So, what's the U vertically? 12.25 sine 25, isn't it? Vertically, the U. This guy here. What's the V? Don't know. What's the A? Vertically. Minus what? No, it is not. It's minus G cos 25. Because gravity is acting at an angle. So we only want the vertical. We're only looking vertically. We're only looking vertically. Vertically. Yeah? No? T we don't know. And what's S? No? 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 What's S? What is S? Zero. What is the vertical height at the end when it hits the plane? Zero. It's on the ground again. Come on, you couldn't have forgotten this. Remember, it goes up and comes down. The S at the end is zero. It's on the ground again. Yeah? Now, see, I can see Gina remembers, but the others, the face on the rest of you. Oh yeah, confusion, and confusion. I highly recommend you re-watch the projectiles lesson. Okay? So I'm going to continue. What formula will give me the, what did I want? The T, wasn't it?
T.
So, S equals U T plus a half A T squared. Cancel the T and we'll get T equals 24.5 sine 25 over 9.81 cos 25. That will be the time. Thank you, Zach. If you can type that in. 1.165.
Yeah.
That seems like a reasonable answer. Yeah? Now, the last thing to get here is what's called the range, which is the distance it travels horizontally. So let's look horizontal now. So horizontally, what's the U?
125.
What's the V? We don't know. What's the A? It's accelerating horizontally with G sine 25. What's the T? 1.165. What's the S? The S is what we want. S equals U T plus a half A T squared. 1.165 squared, and that's that done. Are you okay, Dorian? Looks like you're shocked, or it's tricky, isn't it? That's why I wanted to do it. This is the hardest projectile question I've ever seen in the exam.
17.07. 17.08.
You need to write this down?
No, I was just stuck at yes, yes.
Well, look, let me just see, what's this? Is the C part easy?
Yeah.
Yeah, so let me just
No,
quick.
I don't think any of us decided to do it,
Yeah.
to flip the plane like that.
Well, how did you do it?
I thought like I could cancel out one of the things because the time is the same or something like that, or the distance. But I
Okay.
didn't think to, because they already state the distance would be here. I keep thinking that I would have to.
Okay,
find
okay,
the
fine.
distance.
Let's see what would happen if we did it the way you tried, okay? Will we skip part C because that's okay and just give more time to B? Yeah? Okay, so I'm going to see what the heck happens if I do it the student way. Am I all lined up? Right, so what info do we know about the plane? Is that 25 degrees? So you said that's 25, okay. And then you went, this is horizontally with 12.25 meters per second. And you actually know that this is also 25 degrees. Okay. So let's do this another way, okay? The first thing we want is the time. So it goes up, down, and hits here somewhere, we'll say, in my picture. And it starts here. But obviously the plane extends beyond those 2 points. Like, it continues down here and here. I just don't care about it, okay? Right, so let's do it the student way. We need to look horizontally or vertically? Well, vertically, right? So the U is 0. The V, we don't know. The A is minus 9.81. The T is, we don't know. And the S is, we don't know. However, if I knew this distance, which I'll call or, then I know that this will be or cos 25, and this will be or sine 25. Sorry about my writing there. That's okay, isn't it? So I'm going to write S is minus or sine 25. Okay? Now, I'm also going to look in the direction horizontally. Horizontally, what's U? 12.25. What's V? Don't know. What's A? 0. So actually, when we look horizontally, we can just do remember the distance, speed, time triangle. Yeah. So the distance horizontally is or cos 25. The speed is 12.25. And the time is just t. We don't know. Okay. So let's see what equations we can make and if we can solve this system. So this can give us the equation t equals or cos 25 over 12.25. And what equation uses everything except v and t? Is there one?
Except V and T?
Yeah.
Not really.
V, no.
But if we
S.
C in sign. Like
Yeah, okay, let me rephrase this. I don't care about the V. So which equation doesn't use V?
S.
S equals.
Yeah.
Okay, so guys, look. We know that the T here will be the same as or cos 25 over 12.25. Yeah? So, S equals U, nice, T, plus a half A T squared. Now, what can we solve from this equation? We can get or. And then once we get or, what can we get? T. And so in this case, we're doing the question backwards. We're getting the distance h. I should have called it h, I called it or. We're getting h first and then the time. Now, we still need to solve this. This is or squared and this is or. Well, the minuses cancel, and that or cancels with the square here, leaving me with just one of the ors. So I get or equals sine 25 times 12.25 squared over 4.905 times cos squared 25. And then once I have the or, I can sub it back in to get the t. So, can we check what this or is? And then we'll check what the t is.
So how do you write any sign cos?
Just write cos 25 in two brackets, be the easiest thing. What do we get for or? No, goodness, that's too small. Did I? Oh yeah, because look, there's a 12.25 squared on the top. That's like 144. So that's 4.905. What is it? 15.8 meters. How does that compare to my previous method? Where's it gone? There it is. Oh, that's not so close. 17.1 and 15.8. That's what I got the last time I did it.
I suppose because in that one there was a T and then there is a sign and the cos will be rounded up.
But the problem is the angle is exact. Who gave me the 17.1? Was it you, Lynn? 12.25 cos 25, 1.165. No, it's UT. And then plus 9.81 sine 25 over 2 times 1.165 squared.
And then you can give the mark scheme says it's 15.75.
Okay, so the 17.1 is wrong.
Yeah.
What does it say the time is, Zach?
1.17.
Ah, do you know, hang on, wait, stop. I think part of the problem is, look up. Guys, look up. Look up. I think part of the problem is here I'm using 1.165. Whereas, what did I use over here for the time? No, I did it without finding the time first.
Yeah.
So,
Because the rounding.
I think you're right. I think it's rounding.
It's not, this one is done with 1.65, that's it.
Oh really?
Using what method?
D equals VT. 12.25 times 1.165 equals 14.27 meters. D over H equals cos 25, so H equals D cos 25.
Is there something wrong with the
The velocity times the time.
Can I borrow your calculator, Gina, for a sec?
They do D equals VT, so the horizontal distance.
Teacher thinking. 12.25 times cos 25 times 1.165, isn't it? Plus 4.905 times sine 25. Yeah, this is wrong, dudes. I don't know who typed this in. I'm getting 15.75, so that's 15.8 meters. Okay, so it is the same, which is good. All right, so let me check the t now. I should use 15.75 here times cos 25 divided by 12.25, and I get a time of 1.165, or that's 1.17 seconds. So it's both methods work.
Which one do you think is?
Oh no, it's whichever you prefer. Actually, I thought your method was shorter than my method, but none of you finished it successfully, or did you? I don't know.
I guess you talk about it too late.
Okay. Right, okay, that's nice to wrap it up. Tomorrow, more electricity, more mechanics, or one of each? What do we think?
Electricity.
2 electricities at least?
Yes.
Yeah. Although you didn't exactly impress me with your mechanics today. Now the only thing I'm going to ask you to do tonight is I want you to look at the exams and pick out a good electricity question to do tomorrow, or a couple of them, okay?